Hello there, Mr. Sutton here, bringing you the AB Calculus 3-6 homework solutions on derivatives of trigonometric functions. To find the derivative on this first one, we take a look at the derivative of secant of x. That's going to be secant of x tan of x. And this negative 2 is just along for the ride. You don't need the product rule on this one, and that's it. To find the derivative of this function, we are going to need the quotient rule. So that would be u prime v minus uv prime over v squared. Setting up my box and ribbon for this, I've got my numerator, tan of x, and my denominator, x. And their derivatives down here, that's going to be secant squared of x, and just 1 for the derivative of x. Multiplying that out now, we have secant squared of x times x, so we're using the ribbon here. And now we're going to go the other way, so minus tan of x times 1, which is just tan of x. All of that over x squared. And they said we didn't have to simplify, so we're just going to leave this the way it is. For this problem, to find this derivative, we're going to need to use the product rule. So that would be u prime v plus uv prime. Setting up the box and ribbon, we've got the two factors, negative 5x to the fourth and cotan of x. And now for the derivatives of those, our u prime derivative here, that's going to be negative 20x to the third, using the power rule. Derivative of cotan, that's negative cosecant squared of x. Using the ribbon to put it all together, we've got negative 20x cubed times cotan of x for the u prime v part of this. And then for uv prime, going the other way here, we've got, well, two minuses, that's going to give me a plus. So plus 5x to the fourth times cosecant squared of x. And they didn't want us to simplify this, so we're just going to leave it the way it is and call it a day. To find the derivative on this one, the fastest way is going to be to use the quotient rule, especially since we don't have to simplify. There's other ways to do it if you treat this as 4 over secant and sine over secant and do a little trig simplifying. But, again, quotient rule is going to be faster. So that would be u prime v minus uv prime over v squared. And then setting up my box and ribbon, I've got the numerator, 4 minus sine of x, denominator, secant of x, and the derivatives of those, derivative of 4 minus sine of x, that's going to be negative cosine of x. This 4 just gets differentiated away. Secant's derivative, that's secant of x tan of x. And now let me use the ribbon to put it all together. So we've got negative cosine of x secant of x. And this is where you really have to read the whole don't simplify thing, because we know that these are reciprocals and we could just turn this into negative 1. But let's just keep going. So now we'll do minus all of this stuff times secant of x tan of x. All of that over v squared, that's going to be secant squared of x downstairs. And again, don't simplify, I would take them at their word. For this problem, they want the derivative of this function and they want it simplified. One way you could do this would be to use the quotient rule and then simplify it. A much easier way would be to realize that cosine is the reciprocal of secant. So if I have 4 over cosine, I could just call that 4 secant of x. And now taking the derivative of this one is pretty straightforward. This is just going to be 4 secant of x tan of x. And we're done. That is fully simplified. To find the derivative on this one, we're going to have to first use the quotient rule, and then we'll just kind of pick up the pieces and simplify the mess that results. So that would be u prime v minus uv prime all over v squared. Let's set up the old box and ribbon here. I've got my numerator, cosine of x, my denominator, 1 plus cosine of x, and their derivatives, which are both negative sine of x. All right, using the ribbon to put it together, we've got negative sine of x times 1 plus cosine of x. That's the u prime v part, minus, we've got cosine times negative sine, and we'll simplify that in a second. And then v squared down here, that's going to be 1 plus cosine x quantity squared, which we know we can't just write 1 plus cosine squared. The square does not distribute over addition here. All right, simplifying this, let's clean up this mess upstairs. So I've got, if I distribute this negative sine of x, I've got negative sine of x, and then I'll have minus sine of x cosine of x. Over here, minus minus gives me a plus, so plus, and I'll write it in the same order, sine of x cosine of x. because I realize that these two terms now are exactly the same except that they're opposites. So they actually cancel out those sine x, cosine of x's, leaving us with just negative sine of x upstairs. And that's going to be as simplified as it's going to get. For this problem, for values of h very close to 0, we want to know which function best approximates tan of x plus h minus tan of x over h. Now the key on this one is this wording for values of h very close to 0. So we're basically saying if we take the limit as h approaches 0 of all this stuff, what's our best approximation going to be? Well, when we see something in this form here, this is essentially just the limit form of a derivative. We're taking the derivative of some function. Which function? Well, it's going to be whatever this x plus h is inside of. So in this case, this is really the function f of x equals tan of x. I'll call it g of x because we're approximating this f of x function, but it's essentially the same thing. So we've got g of x equals tan of x. We need the derivative of that to actually approximate this thing. So this is going to be g prime of x, or f of x, is approximately equal to the derivative of tan, which is just secant squared of x. So that ends up being choice E. On this problem, we're given that f of x is sine of x. We want f prime of pi over 3. No calculator problem here. So let's first take the derivative of f of x in general, which f prime of x is going to be cosine of x, the derivative of sine of x. So now f prime of this is really just cosine of pi over 3. Well, this is really just cosine of 60 degrees, which hopefully you remember your unit circle values. This is 1/2, so that was choice B. For this problem, we're trying to figure out the derivative of sine of x cosine of x at pi over 3. So we're going to start by using our product rule on this. There's really no other way to do it that you know of at this point. So that's going to be u prime v plus uv prime. And now, box and ribbon time, we've got sine of x times cosine of x. The derivatives of these, we've got cosine of x and negative sine of x. And pi over 3, I'm actually going to plug that in directly inside the box. And then I'm going to figure out what these values are and put it back together out here. So let's do sine of pi over 3. This is really sine of 60, which is radical 3 over 2. Cosine of 60 is 1/2. Still 1/2 down here for the other cosine. And now negative sine of x is just negative what we got here, negative root 3 over 2. Putting it back together with the ribbon now, I've got 1/2 times itself, plus radical 3 over 2 times negative radical 3 over 2. We do need to simplify this because all the answer choices are simplified. So this is going to be 1/4 minus 3 over 4 if we multiply straight across. Well, that's going to be negative 2/4, which reduces to negative 1/2, giving me answer choice A. For this problem, we're trying to figure out the limit as h approaches 0 of all this craziness. Now, hopefully you recognize that this is the limit form of a derivative. We're really taking the derivative of some function here at pi over 3. Which function are we trying to take the derivative of? What's the original function? Well, I'm going to say f of x equals whatever this pi over 3 plus h is inside of. Sine is the original function here. And this is one of those where you just have to kind of recognize the format and what they're giving you. So if f of x is sine of x, f prime of x then is going to be cosine of x, which means we need to do f prime cosine of x of pi over 3. Cosine of pi over 3 is going to end up being 1/2. So that gives us choice B. For this problem, we're given x over tan of x as a function. We want f prime of pi over 4. So this is one where we're going to have to use the quotient rule and then plug in pi over 4 to whatever we get. So quotient rule, that's u prime v minus uv prime over v squared. Using the box and ribbon to organize things, I've got my numerator of x, denominator of tan of x, and the derivatives. Derivative of x is 1. Derivative of tan of x is secant squared of x. All right, now before I put all this back together, I'm actually going to plug pi over 4 into these 4 parts here. And I'll just reassemble things after I do all this inside the box. So if I plug in pi over 4, x is just going to become pi over 4. Tan of x, this is really tan of 45 degrees, which is 1. That's like the only value of tan I ever remember. 1 is playing itself in this motion picture. And then secant squared of x, this will be a little trickier. So secant by itself of pi over 4, that would be the reciprocal of cosine of pi over 4. Cosine of pi over 4 is root 2 over 2. So secant would be 2 over root 2. Squaring that would give us the square of 2 over root 2. And if I square this, I end up getting 4 over 2, which is just 2 when all is said and done after all that work. All right, let's reassemble this inside the box. So we've got, using my ribbon now, I've got 1 times 1 minus pi over 4 times 2. And that will be dividing by 1 squared. That's our v value here. We do need to simplify this a bit because all the answer choices are simplified. So this is going to be a 1, and this is going to be a minus pi over 2 if we reduce that. So 1 minus pi over 2, all over 1. So when the dust settles, just 1 minus pi over 2, which gives us choice E.